Good day everybody. In this series of lectures on computer organization, I propose to deal with quite a few fundamental aspects, so that you would know what are the basic elements in any computing system and how they interact. Normally, people mix up computer organization and computer architecture. I would also identify both these and then tell where the stress is in what. Good. Now, let us start with the very word computer. Essentially, this has come about with the root compute, which means we have some, let us say, numbers, and then there is some computation to be done on these numbers. Okay, this is how the whole thing started. Fine. But now today we also see that apart from, let us say, processing these numbers, that is carrying out some kind of a process, there is also the other one, that is communicating. That is, we keep seeing that computers are widely used for communication purpose. So, this in fact has come about of late. So, we will start with the original one, that is processing, and that too with the processing of numbers. Well, we saw that computers are essentially used for processing, and I said that is how the whole thing started, that is historically speaking. That means basically any computing system will consist of a processor for, of course, carrying out processing, then memory. So, essentially these two are the elements, that is processor for carrying out the processing and memory essentially to store the numbers. Okay. Now, in addition to these, we also have what we may call simply as I/O or input output. Later on I will tell the relation between input output as memory, because in fact I would say input output is an extended memory. What did I say about memory? I said store the numbers. The same way input output also will store the numbers, but though in a different form. Okay, we will come to this I/O later on. Not only that, there is also another aspect of this input output, that is, in case we consider the computer system as a machine, then input output is one which helps man to interact with the system. Okay, so there is another aspect of it. We will come back to this. So, I would say that the processor, which essentially in those days it was called a central processing unit or just CPU, okay, central processing unit, mainly because processing in those days was centralized and the hardware was in one place, etc. I mean, that is how they got the word. Fine. Now, today we talk about not central but distributed processing and so on and so forth. Okay, we will come to that later. Now, so CPU, the historical word central processing unit, and the memory. So, these are the two things. Now, I will just briefly indicate to you, say supposing we have this block CPU for central processing, and then let us say the memory. Let me just use just a different symbol for this. Now, it is like this, we have the data stored in the memory and the CPU is capable of processing. So, what the processor will do is to keep addressing the memory and carry out, it will get the data from the memory, then it will carry out some processing. Okay. So, essentially the whole computer organization boils down to having two main units, one for processing and one for storage, right. Already I said I/O or input output, I would call it as extended memory, in which case essentially what we have in any computing system is processor and memory. So, that is what the particular thing is. Good. Now, what is this particular processor will consist of? Obviously, the processor is the one which is going to deal with the data, and so the processor must be able to set up some kind of a path, okay, to deal rather to handle the data. So, data path setting, this is one aspect of the processor. Now, apart from this setting the path for the data to be processed, it should also be able to carry out the processing through a sequence of control signals. So, again what we see here is the processor will essentially consist of data path circuits and control circuits. And memory, as I said, is for storing, and the one which would directly interact with the CPU part is still called memory. The one which would interact with the CPU but not directly is called the storage. Okay. Though I was using the word storage as earlier to store the numbers in memory, it so happens that now the one which is closer to the CPU has come to be called memory. The one further from CPU but still effectively stores information or data is called the storage. For instance, we will talk about magnetic tapes, disk system, all these things in this storage, whereas semiconductor, say RAMs, that is random access memory, read only memory, all these things will be coming under this particular category. Okay. Fine. For the moment we will just define the IO port also. Okay. So, we will deal with it a little later. I would just say I would put it as I had said earlier, that essentially it is for man machine interface all right. Then there is another aspect to this. Depending on the kind of processor or the kind of computing system, the system may take the data from the memory, which means it is the data which had already been stored in the memory, or it may take the data from the input output system directly, which means from the external world, or we may say the real world data. Fine. So, we may have the data coming directly from the real world through the IO devices, or you may have the data which has been previously stored in the memory or storage. So, this way you can say that the memory and IO, they are not really different, which means that is why I said IO can be considered as extended memory. And later we will see in detail the CPU deals with the memory in almost the same way in which the CPU will also deal with the IO. Fine. Okay. This is one aspect of it. And while starting this series, I said people generally mix up computer organization and architecture. In fact, in some places many people do not even make any distinction between these. There is a slight difference. I will just tell you that is the organization, what does it deal with, and vis-a-vis the architecture part. There are two things. Okay. So, I will take one and then set the other against that. We can study a computer system either from the user's point of view or from the designer's point of view. Good. I think these two different viewpoints really hold good with any system, is it not? For instance, we talk about say something like a car driver and a car mechanic here, the same way here too. So, the organization is study of computer system from the user's point of view, and the architecture is study of the same system from the designer's point of view. I will explain this further through an example. Now, let us take an example. Suppose your computing system has a multiplier. From the organization point of view, it is enough if we know that the system has a multiplier, right? One need not know how exactly this multiplier is designed or implemented. The same way, if you take a set of instruction, okay, which we just call instruction set, it is enough if the user knows what exactly is the set of instructions in this particular one. He need not really know how this instruction is implemented, whereas how these things are implemented is in fact the emphasis in the case of architectural studies. I hope now you got the point. How these are implemented is from the architectural point, that is the designer point of view. For instance, a multiplier, well, everyone knows what it is, that is it takes two numbers minimum and then it gives out a product, that is good enough. How exactly it is implemented in fact is from the architectural point of view. Good. So, we may say that this is essentially from we can call it as a programmers being the essential users, whereas this particular one is well, we will just call them as designers. Okay. So, this I can call this organization is study of computer system from programmer's point of view, because the programmer must know whether a separate multiplication instruction is there or whether it has to be done through a set of instructions. Okay. The architecture of the system, that is the designer, is in fact must worry about how it is implemented, what is the algorithm of implementation, and depending on this there can be different types of multiplier units. This man does not really bother about it. Good. So, I may without loss of generality I may subsequently also say that essentially that the organization is study of the system from software point of view, whereas architecture is study of the system from hardware point of view, as being essentially designer. Now, you may ask, what if you have someone whom you may call as a software engineer, because he is also a designer? Yeah, true, he designs the software system, but essentially he does it from the user point of view. Similarly, here there can be different levels of designer. For instance, you can think of a system software designer, application software designer, you see. So, be careful when we mix up, when we try to identify a programmer and designer as two different things, you must be very careful about what we are talking about. So, I hope you understand that essentially the study of the system is from the for the organization is from user point of view, architecture from designer point of view. In other words, when we talk about architecture, we would go more and more into the details of how the system is implemented, whereas here we will have a description, an overall description of the system, right. So, from the organization point of view, you can just see we can sort of summarize and say processor, then you have memory. Then what are the types of processors, what are the types of memory? Okay. We may not go into the details of a processor or the memory, fine, that is it. Good. Having provided this particular introduction, I would now give you further information from a slightly different point of view. What is that? Because I said organization is essentially from user's point of view. The best thing is to start with what we may call as an application spectrum, because essentially any user is concerned with the application, that is how and where a particular system is going to be used. So, what is this application spectrum? We may say broadly that at one end we have what we may call as control applications, which I would say a bit loosely as essentially an electrical engineer's viewpoint. And at the other end we can say again a little loosely as data processing end. And I would say that the focus of this particular thing is essentially a computer scientist's viewpoint. Fine. I would say this end we have electrical engineering, at the other end we have computer science. Fine. Now, what is this? Are they really, is it that the application spectrum gets really divided into these two ends rather mutually exclusively? No, it is not really so. There will be some applications, for instance, which might need control in data processing and data processing in control also. That also is very much there, but we can broadly have these two classifications. Now, why do we have to really do that? It is like this. Any control applications will be special purpose applications. Okay. You know precisely what the inputs for the system are, and you also know where exactly these outputs from the system will be used. Whereas at the other end it is very general. So, it is a general purpose, you might say. Here we really do not know what the purpose is. There will be a wide range of users, whereas here it will be a narrow range or even one specific user for that matter. Okay. In the general purpose we really do not know. In other words, suppose we have say a software. Since we know for what purpose this is being used, that software can be packed and put in a read only memory. I am talking about the program itself. The program can be put in the read only memory, whereas in this particular one we just do not know who the user is. So, we must allow that this particular user, whoever it may be, there will be different types of users. So, those users will have to load their program in RAM, that is random access memory. That is, here we have a loadable memory. The program will be loaded by the different users. Here you have a program which is frozen and canned and put once for all, because we know what the purpose is, right. In other words, we may say this particular one is more say hardware oriented. Okay. Even if you have a program, that is, you do have some software program, but it essentially it is hardware oriented, that the program is used for some hardware application, whereas at this end we have the software application, because we really do not know what this end use is. Fine. So, I hope you are able to see how we are able to distinguish between these two. Again, you want to ask me whether in control applications whether RAMs will not be used, they will be used, and in data processing applications whether ROMs will not be used, they will be used. As I said earlier, they are not really mutually exclusive, but broadly you can classify these two. So, this starting with application, this is how we have to really study a computing system, because depending on this particular one, the type of issues, whether they are data processing oriented, whether they are control oriented, or in other way say whether it is electrical engineering oriented, whether it is computer science oriented, all these issues will keep emerging and one will have to study them very closely. Good. And it is very interesting that these days almost everyone knows about computer, of course. They also know a microprocessor. Really somewhere at this end of this entire spectrum, a microprocessor started. Okay. A microprocessor started at this end. What exactly is the characteristic? There are many things we can talk about, at least one I would say. Say, suppose the width of the data that is being processed is say 1 bit at this end, okay, at 1 bit at this end, The microprocessors evolution started with 4 and then subsequently 8-bit and then subsequently 16 and 32, 64 and so on, it keeps going. So, you can really say that in the case of data processing, the data width is more. In the case of control application, generally the data width is less. And microprocessor started with 4-bit, then evolved and so on so forth. Now, though microprocessor started with control application essentially in mind, of late almost all the processors, almost all the computer systems, especially desktop systems, they all use microprocessors, but they are all from data processing point of view. Fine, good. So, this is a nice picture one should have in mind while talking about this. Now, right at the beginning I was talking I was telling something like, apart from computing there is another thing, that is communicating. I will touch upon this point a little later, because suddenly it came to my mind that there is something else I need to talk about. There is the computing, I said, essentially consisting of processing and storing. Good. I also said processing means essentially processing some data. What type of data? We said numbers. Okay. We said numbers. Good. It all started with that. And of course, storing of it also was very much part of it. And later on, well, we will come to this a little later. Later on, communicating, when it came, what exactly is the history of communication? It started with line communication, say telephones, earlier there was telegraphy and so on and so forth. Now, we talk about data communications in which computers also play a role. Okay. Now, when we use computers for communication, again processing, storing, all these things are very much involved. It is not that it is entirely a different story altogether. Okay. Now, do you recall that I said computing started with the word compute the numbers, then we said process, then store. Now, more than processing, the present day computers are used for storing and retrieval purpose, and that in fact is the starting point of even the information technology. Fine. What is it? It is not just computing using numbers, it is storing some data, and a set of data will convey some information to the actual users. Good. So, from data we progress further up to information. Now, when it comes to information, it is not really processing the data, it is storing the information and retrieving the information. So, it is not only just processing, but also storing. And so, in fact, the focus of issues has shifted from CPU to memory or storage. Now, that is of course because of the advances in the semiconductor technology. As I said earlier, that processors started growing, it started with control purpose and then started going towards data processing, and then I said 4-bit, 8-bit processor, 16-bit, 32-bit processors and so on. Now, this particular advance has been so much that simultaneously the technology advances in processing had also influenced the memory which has been used for storing. And so, now given that processors are quite powerful enough, now it is no more much of a problem, it is not posing much of a problem. It is storing, how much can we store? Now, in fact, issues have gone in that particular direction. Good, we will go back. Well, it all started with processing, that is the processing the numbers, and so the main thing in processing is numeric processing. That is what is numeric, that is processing the numbers. Okay, numeric processing, that is processing the numbers. And when we talk about numeric processing, essentially it is taking say more than one number and then carrying out some arithmetic, fine. So, we may say any particular numeric processing will essentially involve arithmetic processing. Then subsequently, this numeric processing, in addition to this particular numeric processing, we also have what is known as what has been come to known as symbolic processing. What is this actually? Earlier, computing using numbers, that is processing the numbers, and so numeric. Now, instead of numeric, now the processing is confined to some symbols. It is not just numbers. Numbers may be there, but actually the numbers represent some symbols. Okay. For instance, a name, okay, that is a symbol, a string of characters. Now, that is a symbol. Even a letter, a character A, B, C, D or whatever it is, or let us say a particular string such as say RAM. Now, that is one symbol. Okay. And anything else, for instance, another name Gopal. Now, this is a symbol, a name, an address. Okay, these are all symbols. Fine. Now, this symbolic processing, this particular symbolic processing needed what we may call as logic processing, mainly because this kind of processing does not involve numbers, but one has to carry out some logic processing on these symbols. So, essentially it is the arithmetic processing and the subsequent logic processing. Now, these two have come together and the core of any specific CPU or processing is ALU. What does that A and L stand for? A for arithmetic and L for logic, and U is just for the unit. Okay. Now, ALU is the core of CPU, that is the essential thing of any processing unit. So, you can see from CPU, we are just seeing some detail of CPU, essentially that is the ALU, arithmetic and logic unit, and it had come about because it all started with numeric processing, that is arithmetic processing, and subsequently it evolved into symbolic processing, that is logic processing, and now essentially we have this particular ALU unit, which is the essential core of the processing unit. Good. And let us not forget about the other aspect which has come about, that is communicating. I said earlier this communicating means essentially it all started with say telephone and so on. So, we may say in the case of telephone, voice communication is the main thing. Now, after this voice communication over the same wires, even data which were essentially used for processing computers, even data was being transmitted over the same say copper set of copper wires and so on. Now, it so happens because of what we may call as the advance in digitization, okay, digitization, the same voice can be converted into some coded data, and the coded data can also be used in this particular case. So, you can see that earlier there was computing and then the arithmetic, logic, processing, etc. we saw. Now, we are seeing because computers have become cheaper, processors have become cheaper, and more memories are being used, then they thought it is not just one computer, but a set of computers, and these computers are connected over a set of wires, and the set of wires are already there, for instance telephone, for telephone communication. So, now computers to computer communication, but what we are using is say if you are trying to use the same set of wires which you use for telephone channels, then essentially earlier with telephone equipments we are sending out the voice, but using the same thing now data which computers are familiar with, okay, they can be used, but voice also can be sent over the same thing using coded data. So, now this is how things have been in fact advancing. So, from computers now we have come to network of computers, okay, and these networks are in fact supported by these interconnecting communication lines. Good. Now, what has happened is originally we started with numbers, I said, and then when symbols came, you can see that some symbols such as this could be used. And what exactly are these? These are nothing but what I may call as text, as part of text, that is you can see that each one is a word, right. So, I can say that each one is a part of text. So, first it was numeric or number processing, then it had come out as text processing, good, and then after text what else? Say simple picture elements, and so using these picture elements you can say depict good graphs or graphics capability, fine. See how things have progressed from numbers to words are part of text, and after text some primitive elements of graphics, and meanwhile because communication also has become very much part of this whole thing, now we can add voice, in other words say audio. Well, when we talk about audio, the next thing obviously is video, good. Now, today in today's computers can support text, graphics, audio and video. That is why we say the information or the data is coming in multiple forms, and it can come in the form of text or graphics or audio or video, or we talk about different types of media, and that is precisely what a multimedia computer is, good. So, from simple numeric processing which is historical, today we have advanced to multimedia. Now, this whole thing has been supported mainly because of these advances in semiconductor technology, I would put it. First it started with processors, then subsequently memory, and later on we will talk about the I/O part. Today we know that the data can come in the form of these, which means the information is available to the user over different media. Now, compared with text or graphics, there are storage issues related to audio and video, mainly because essentially audio and video they are all signals. Now, these signals must be coded, and they also when coded, the number of codes which will have to be transmitted for reproducing this audio or replaying the video, etc., these things take a lot of space. So, compared with these, the storage issues have come about with this, okay. And because of the communication, again communication related issues are very much there. So, storage issues and communication issues are there, whereas in the case of text, let us say suppose we talk about some kind of a set of data in a database, say employees record, his name, address, okay, the category of employee, etc., etc. All these things we can easily create using what known as records in the text. The same thing you cannot do with audio and video, because these we generally call them as unstructured data. You can bring in a structure for this, but in the case of audio and video there is no structure. For instance, given a particular audio, generally it is called a clip, okay. There is a specific duration, say for 1 minute or half a minute or whatever be the duration for 1 minute, an audio clip or a video clip. So, if you have to describe how it is, a man can do, because he has very good information processing capability, but can a machine do? These are the issues that are coming up. So, what we call generally as semantic issues. Good. So, the case of computer organization, in the case of multimedia, we have got to deal with all these issues also. It all depends on what type of system one is going to use. Good. Now, I will take up the next one. Fine. What is next? The next thing is, in fact, going back to the beginning, in fact, what is it we said? Said organization is essentially from user point of view, that is with the software bias or emphasis. But let us not forget that architecture is very much part of the whole show, in the sense that the hardware is the core of the entire system. Okay? This is the core. And when we talk about organization, around this core, we will be talking about different layers and layers and layers of software. So, all these things, okay, they will all be software. Why in fact the very term software had come in? That is interesting. We will take a look at that first, because the hardware is really hard for every person or every user to understand. Now, given this hardware, you are going to soften this particular system by providing certain features or layers, so that one need not really be concerned with the hard aspects of the system. One need only be familiar with certain soft aspects of the system. Now, historically things had grown in such a way that more and more layers of software had come about. Why so? Mainly again because of the advances in technology. What is that? Initially it all started like this. A person using a computer must be familiar with the inner details of the processor or the system. In other words, there was not much distinction between organization architecture. That is how it was really. That is, a person dealing with the hardware must know what generally we call as some machine details, and if he is going to do the programming, he must know the codes related to that particular machine. In other words, the program will consist of, you remember historically it was all numbers. So, a program will consist of a string of numbers. What are the numbers in this computing system? They are binary numbers. Being digital computers, we have binary numbers. So, one talks about some kind of a string of digits like this, okay, that is bit 0 or bit 1 and so on and so forth. So, this particular is possibly a machine code conveying some information like, let us say this part of the code will convey something and this part of the code will convey something else. Now, let us go back and recall. We said numbers are used for carrying out some arithmetic processing. So, it is meaningful to understand, fine, this part let us say is the operand or the data, fine, and this part refers to the operation. What is that operation? Originally it is arithmetic operation. So, this is a code related to operation, and this is either code or that itself is operand. It all depends on how you talk about. In other words, we have the data here, data part here, and we have a code which relates to operation, and so generally this is called an opcode. Now, imagine a particular programmer must know these details at this very low levels, because it is at this low level like a particular active device, say 0 means it is not conducting, 1 means it is conducting. That is, at the physical level of the machine, one must know what is going on. So, this is very difficult to remember, but that is hardware. Okay. The hard part of it is that. So, to soften this, one introduces other levels of codes. So, one goes out from machine code to lesser and lesser say lesser and lesser details. That is, one we are trying to sort of hide the hard information, meaning instead of doing it this way, suppose this particular one corresponds to, let us say this opcode corresponds to add, and then this particular data some number, let us just call for instance A, right. If you are more familiar, let us say this particular thing refers to say A B. Now, instead of this code, the user can easily remember this, which means add A B means possibly A and B will be added, and the result will be the sum of this. That is what it is. So, now instead of this code, which is the machine code, if one can use this code, what is this code? What is specialty about this code? This particular thing actually helps the user to remember. In other words, these are generally called mnemonic codes. Mnemonic means aiding the memory. Mnemonic codes aiding the, of course, what is the memory? Memory of the user, not the memory of the system. Mnemonic aiding the memory of the user. So, the user can remember this better than this, agreed? Which means we have gone one layer away from the heart. Instead of a string of 0 1 1 0, we have to have some layer which helps the software developer or the user to remember, and when he comes out, he does not have to remember 0 1 1 0, it is enough if he knows it is add. And add for addition, say sub, say for subtraction, and div for division, and so on so forth. It is easy to remember, one need not try very hard to remember this, fine. Now, so from machine code we have gone to the next level. These codes still at a lower level. Why? Because in each pattern like this, add A comma B or whatever it is, we are only specifying one operation, right. Now, the next higher level we will go on. Suppose if we have an equation, so we have gone from this to this, now we will go to a higher level, where suppose if you can write something like this, x equals y plus z. Now, what is it that we have here? We have in fact a function. So, at this level we are no more talking about just a code, we talk about a statement, right. It basically it means add y and z and store it as x. So, in fact, this is something more than this. So, you can see from machine code, just writing MC for machine. From machine code, we have gone to the next level, that is mnemonic codes, but then these mnemonic codes will be specific to your machine, and generally it is called that particular mnemonic code will be called an assembler code. Now, from the assembler code we go to a higher level, generally it is called, can be called a code, generally it is called a high level language code. More than code, we may just call it a statement in a given language, fine. So, we go from the harder aspects to softer aspects, in the sense that at this level we can talk about different languages. For instance, Fortran is one, it is a very famous one, very old one. Now, Pascal is another, now BASIC is another, and so on. Now, these are all high level. languages, fine. So, now the user is going to write his program in this high level language, which is much better than doing at machine code level. Why? Because at the machine code level, the user must know the inner details of the processor or the system, and the moment we talk about inner details, it is going to vary from processor to processor, from system to system, because the CPU memory interaction can be different from different things, agreed. And we have also said that that is more from architecture point of view. Why should one be really bothered about the details of a car if one knows certain minimum things about car driving? Okay? Of course, if the car breaks down, he should know, that is a different matter altogether, but he can always call a car mechanic and have this particular thing fixed. So, one need not know more details, one need know only the functional details of the machine that he is going to use. Now, from machine code we have gone to assembler code because of computer, then from assembler code we have gone to high level language code or statement in a language. Now, what does it really mean? If one writes a program in this particular one, then one should have the appropriate code, another set of codes to translate from here to this. If one writes from here, similarly one must have another software to translate from this to this. Why? Because ultimately in any system, these are the codes which will be accepted by the hardware, agreed. The hardware knows only this. It is only the user who is trying to be away from this, mainly because he is aided by the appropriate software, he is writing these codes, but inside internally one needs machine code, right. So, to write a program one uses a high level language, but finally when the program is run, it is all string of zeros and ones and so forth. We are only telling that the user is hidden, or rather the details of a hardware is hidden from the user, agreed. So, we need the necessary software or the program which can translate from this to this, this to this, and this is how in fact the software has been growing. Okay? That is precisely what it is. Good. So, we may just conclude for today saying that we need to have the necessary program called translators, right, basically to translate from one code to another code. Then tomorrow we will continue and then see that the translators can be different types depending on from which level to which level and so on. And this is how the software has been going on. That is, at this level it is a machine code, at another level it is an assembler code, at the third level it is a high level language code, but to see that the user may write his program at this, he needs to have appropriate programs which can translate this, and that is what the translator is about.